So to get started, first up we have Mr. Jack Branby. You are junior?
Senior. Going to be a senior.
Jack is a rising senior at the College of St. Scholastica in Duluth, Minnesota. His mentor is Dr. Laura Hansen in the Department of Biomedical Sciences.
Good morning. So, my name is Jack Branby. I'll be a senior at the College of St. Scholastica this fall. This summer, I looked at pro-P antioxidant enzymes and UV-induced DNA damage in the Hansen lab. So, in order to understand my project, In order to understand my project a little bit more, we need to first talk about the different UV wavelengths. First is UVC. This is the shortest wavelength. It doesn't reach the Earth thanks to the ozone layer, and it's harmless unless you're in space. The second is UVB. It does reach the Earth, it affects the top skin layer, and causes most burns and skin cancers. The third is UVA. It's the longest wavelength. It's used in tanning beds and causes skin aging and DNA damage. So, skin cancer. Skin cancer is the most common form of cancer. More Americans are diagnosed with skin cancer than all other cancers combined. In the United States, more than 9,500 people are diagnosed with skin cancer every day. More than 2 people die of the disease every hour, and the annual cost of skin cancer treatment in the US is around $8.1 billion. There are 2 different types of skin cancer, non-melanoma and melanoma. Melanoma skin cancer develops in the melanocytes located deep in the basal layer of the epidermis. This type of skin cancer is not as common, but it is far more serious. Non-melanoma skin cancer consists of basal and squamous cell carcinomas. Basal cell carcinoma is the most common form of skin cancer, but is by far the least harmful. 90% of non-melanoma cancers are associated with the UVA and UVB wavelengths I discussed earlier. Reactive oxygen species are highly reactive chemicals formed from O2 exposed to UV and produce superoxide radicals. As we can see in the diagram on the left, the UV is exposed to the oxygen and goes through several chemical processes resulting in DNA damage. This DNA damage can lead to the promotion of cell death in the epidermis, which often leads to cancer formation. There are 3 different types of DNA damage caused by reactive oxygen species that I looked at this summer. Cyclobutane pyrimidine dimers, gamma-H2AX, and 8-oxodeoxyguanosine. The one I looked at primarily this summer is cyclobutane pyrimidine dimers, or CPD. CPD is the primary lesion most involved in skin cancers caused by UVB radiation. These lesions are generally repaired prior to DNA replication in basal keratinocytes. However, if they are not repaired, they could lead to cancer-causing mutations. Due to the incorrect use of modern sunscreens coupled with longer periods of sun exposure, the wealthiest countries' populations are experiencing an increase in UV radiation. This leads to the increase in CPD formation in the epidermis. So, let's talk about pro-P. Pro-P is a topical FDA-approved Gram-Sil GCM5 lotion along with polylactic coglycolic acid nanoparticles. These nanoparticles contain 2 antioxidant enzymes, superoxide dismutase and catalase. The key benefits of pro-P are a reduction in the reactive oxygen species induced by UV, and if added to sunscreens, you would only have to apply these once a day for sun protection. So, can pro-P reduce the buildup of UV-induced DNA damage? Well, our lab's hypothesis is that pro-P antioxidant enzymes topically administered via nanoparticles will reduce UV-induced DNA damage. The aim for this project was to show this in pig epidermis. So, there were 3 different treatments to the pig epidermis of UV exposure: lotion without UV, lotion with UV, and lotion with pro-P UV. There were also 3 different collection times at which these samples were exposed to UV, 1, 4, and 12 hours. In order to see the effects of the Pro-MP treatment, I needed to complete indirect immunofluorescence on the samples. So, this immunofluorescence process included deparaffinization and antigen retrieval prior to myself putting the primary antibody onto the tissue to see if it would connect to the antigens. These samples were incubated for a day at room temperature, and then after that I applied the secondary antibody and fluorophores in order to produce the images you'll see next. So, these are the CPD immunofluorescence images, and you can see that there's lotion no UV, lotion with UV, and Pro-MP with UV slides here. These are all slides from year 4. We can see that there's a channel called DAPI, and this channel basically is just trying to show us the thicker blue outer portion of the tissue, which is the epidermis, and the inner, less nuclear stained portion, which is the dermis. So we can see that the cells were decently stained in these samples. If we go over to the CPD sections, we can see that in the lotion no UV, there's hardly any signal, and you can probably barely even see anything back there. This channel was supposed to represent the positive signal that we would see from cyclobutane pyrimidine dimers. Now we can see that in the lotion with UV, there are quite a few positive cells in that epidermis, and the Pro-MP with UV, there are some sporadic, if less fluorescent than the lotion with UV. Now the overlay is meant to demonstrate the actual signal, the positive signal from these CPD cells. We can see in the overlay of the lotion no UV that there's not any signal, and that's to be expected as it wasn't exposed to UV. There's quite a bit of this positive signal here in the lotion with UV. We know that these are positive because we overlaid the DAPI and the CPD channels, and if these cells line up, that means we have a positive cell. And the Pro-MP with UV is a little bit more stained than the no UV, but just a little less than the lotion with UV. So, this graph shows the mean fluorescence intensity, which I analyzed using a software specifically counting only CPD positive cells. These data demonstrate the UV exposure increases CPD in pig epidermis. We can see that the black bar is very low, indicating the lotion no UV, and the middle bar indicating lotion with UV is significantly higher. So this means that the UV exposure worked in doing this. We can also see that at 4 and 12-hour time periods, the Pro-MP appeared to reduce the amount of CPD signal relative to the lotion with UV, noted by the reduction from bars 2 to 3 in the 4 and 12-hour time periods. Unfortunately, this difference was not statistically significant due to the small difference in positive CPD cells between Pro-MP and lotion UV. This also was statistically insignificant because of how big our error bars were, just because there were only 4 samples that we could draw from, meaning there wouldn't be significant evidence to conclude on whether Pro-MP really had this dramatic effect of decreasing the CPD signal. This is the gamma H2AX immunofluorescence, and you'll see that the DAPI looks very similar to the CPD, but the gamma H2AX portion doesn't look incredibly similar to the CPD, especially in the lotion with UV section. You can see if you look very closely, there are a few tiny cells of positive right here. Unfortunately, our staining for these slides did not produce the results that we had indicated that we wanted in the hypothesis. That wasn't because it either had a reduction or not. These are just supposed to show whether or not the UV exposure worked in inducing these gamma H2AX cells, and fortunately this was unsuccessful. So, 8-oxodeoxyguanosine was the last marker for reactive oxygen species-induced DNA damage I looked at. Unfortunately, this marker was even less quantifiable than the gamma H2AX samples due to the smaller amount of positive cells on the epidermal imaging. These samples could be assayed further to see if Pro-NP reduces this marker, but unfortunately there wasn't enough time this summer. In conclusion, while it appears Pro-NP reduced CPD formation, the results weren't statistically significant. To determine whether the effect is real, these experiments should be repeated with more samples. Since the gamma H2AX data was uninterpretable, a different antibody or protocol may yield quantifiable results. There have been previous studies on both CPD and gamma H2AX which produced more significant data. Although these studies were exposing their mice to UV radiation for a 2-week time frame. This is different from our experiment because ours included 1, 4, and 12-hour time frames rather than a 2-week longer extended period of UV radiation. This could help in the process of figuring out just the effect that gamma H2AX and 8-oxodeoxyguanosine have in reaction to Pro-NP. I'd like to thank all the Hansen Lab staff for allowing me to learn and help with their Pro-NP project, along with a few others for funding and references. Any questions?
So I may have misheard you, but when you were doing the immunofluorescence staining for the CPD, were you staining for the CPD itself, or did I hear you mention you were staining for a channel?
So when I'm referring to channel, we used a microscope with DAPI and what's called TRITC channels. The DAPI channel is meant to see just the DAPI staining, which is the nuclear staining of the cells in the epidermis, while the TRITC channel is generally used to see our cyclobutane pyrimidine dimers, our gamma H2AX, and our 8-oxodeoxyguanosine cells. So it's meant to see the antibody or the DNA damage marker that we were looking at.
And you mentioned in the future using different methods to kind of measure some of those harder to quantify reactive oxygen species. What would be your strategy for that? Are there other ways of measuring those reactive oxygen species other than immunofluorescence?
Yeah, so I didn't come across any other ways to quantify those results. I know in the CPD, I used a software to create a region of interest, which calculated those positive results for me. Whereas in the gamma H2AX and 8-oxodeoxyguanosine samples, there wasn't that software that could pick that up. And so I had to do those by hand. So it was kind of a hearsay, is this positive, is that positive? So if there was some sort of software or some protocol in which there was a little bit more of an automated calculation of those positive cells, that would help. Also, I had mentioned that the UV exposure in the mice studies was 2 weeks long, which could just produce more gamma H2AX and 8-oxodeoxyguanosine positive cells to look at. Because we're not sure whether it was the antibodies we used, the protocols, or the amount of UV that we exposed them to.
One more question. Last question. Would you buy Pro-NP lotion?
At this point, I would have to say maybe. I know there's the founder of Pro-Transit Nanotherapy, the producers of Pro-NP. He uses it every day, and he's noticed significant reduction in sunspots and wrinkles. So there might be something to that, but I definitely have to trust the further testing a little bit more.
Thank you.
Hi, my question was a clarification. When you say the lotion, so the lotion was the base lotion of the Pro-NP lotion, and then the NP was the same lotion base with NP enzyme in it.
Yep, the lotion is, just the lotion is the Gransil GCM5.
Right, so it's the base. So because obviously I'm not Googling or checking anything here, but I would like to know whether that was a chemical sunscreen, like avobenzone or something like that, or did it contain something that is a physical sunscreen like titanium? nanoparticles or microparticles? Do you know? Did
So-
they tell you, or is that proprietary?
I believe that it was more on the side of a topical moisturizing lotion, or just the base for the Pro MP lotion without the nanoparticles. I know Jim can speak a little bit more to that. Dr. Grunkmeyer, who was one of my mentors.
There's no sunscreen, no filtering component. It's just a silicone-based vehicle, basically, for the nanoparticles.
So the lotion itself is just the silicone base, and then you're adding the Pro NP to it?
Yes.
And that's what Jack was testing?
Yes.
Okay, thank you for that clarification. Yeah, because it just seems that, I guess, for me, that's a lot to expect from an enzyme, but it's very promising, so it's interesting. So, do you think that they should continue, this is a speculation question, so do you think that they should continue to test it alone? Or do you think that maybe they should layer in a little bit more protection from a chemical sunscreen or a particulate-based sunscreen like titanium dioxide or zinc oxide?
That's a good question. I think definitely they should repeat the project that I had done to see if there are more DNA damage markers that could be reduced, more than just the CPD that I had noticed. But I think different, like in the further experiments section, I think further experiments including maybe, including the Pro MP in some sort of sunscreen formula would be something that would be interesting to look at. It would be nice to get a little bit more concrete evidence that Pro MP itself has an effect on the epidermis rather than combining it with other chemicals before doing that. But
can you go back to the immunofluorescence stainings? Yeah, it's for that one. Let's start there. So you show that the motion plus UV has a pretty strong staining, and it seems to be less. So with the Pro NP plus UV, at least visually, and you chose to look at it on a sort of a per CPD basis, but I wonder why you did it that way as opposed to just looking at the absolute number of CPD spots that you see per DAPI spot.
So like looking at the overlay compared to.
Right. Well, so that it seems like the absolute number of those spots is diminished, but I can't. You seem to choose to look at the fluorescence per cell, as opposed to the fluorescence per total cells. You see what I'm saying?
You're talking about the number?
Yeah, so it's going to hit the skin, right? And then the outer skin layers are going to probably be more, susceptible to having UV damage. And the question is, does the Pro NP reduce the penetration and fewer spots as you get further into the skin? I mean, have you quantified it that way?
I just used the software to completely surround the entirety of the epidermis. I didn't look at it in terms of the levels of the epidermis. We were specifically looking more towards the basal layer, or the deeper layer, which is where the melanoma cancers arise from.
Can you go to the next slide?
Yeah.
Or not the next slide with the H2AX. Yeah. So you said that this didn't work, but it looks like the gamma H2X is staining it very brightly along, the outer edge of the ear. I think that's the outer edge. So why do you say it didn't work?
Well,
did you have a fluorescent, an isotype control antibody that was similarly labeled to show that it didn't stain, or?
How the samples are done on each slide, there are 3 different shavings of the samples.
Okay.
We did a no primary, one at a smaller dilution and one at a larger dilution. And so we were able to look at the 2 dilutions with the no primary alongside it. And the no primary the no primary rather, generally indicates just all of the background staining and not the nuclear staining that we were supposed to see. And so the difference between the antibody, the secondary antibody, which was supposed to look for the gamma H2AX, and just the background staining, that wasn't significant enough to.
I see. So you saw the staining, same staining pattern with the no primary control.
Yep.
I see. Okay, that makes more sense now. Okay, great. Thank you.